In the next exam question, we have a momentum versus time graph for an object A originally moving horizontally east. This means that everything above my x-axis is east and everything below is west. Interpretation of the graph shows us that between 0 and 30 seconds, as well as after 50 seconds, object A is moving east, and between 30 and 50 seconds, object A was moving to the west. Between 10 and 20 seconds, as well as after 50 seconds, object A has a constant momentum. At my 50-second mark, there is a sharp change in momentum between negative 120 to a positive 50. So this indicates a collision. Now that we have looked at the graph in detail, we can answer the questions. 4.1 asks to write down the definition of momentum in words. Please note that they ask us to define momentum and not the law of conservation of linear momentum. So when we need to define momentum, we can do it by making use of the momentum formula, which states that momentum is equal to the mass times velocity. (4.2) says that the net force acting on object A is 0 between 10 and 20 seconds. Use the graph and a relevant equation to explain why this statement is true. From our graph, we can see that between 10 and 20 seconds, we have a constant momentum. If we need to calculate the net force, according to Newton's second law in terms of momentum, the net force would be equal to the change in momentum over the change in time. Seeing as my final momentum is 50 and my initial momentum is 50, I have a change of momentum of 0, and therefore the net force is equal to 0. 4.3 says calculate the magnitude of the impulse that object A experiences between 20 and 50 seconds. Now between 20 and 50 seconds, we are looking at this part of the graph, where we have an initial momentum of 50 and a final momentum of negative 120. Now in order to calculate impulse, we can use one of the following formulas. Now, seeing as we have the change in momentum between 50 and 20 seconds, we can use P final minus P initial, which gives you a value of 170 kilogram per meter per second west. 4.4 says that at t equals 50 seconds, object A collides with another object B, which has a momentum of 70 kilogram per meter per second east. Use the information from the graph and the relevant principle to calculate the momentum of object B after the collision for a total of 5 marks. Looking at the time 50 seconds, we can see that my object A has an initial momentum of negative 120 and a final momentum of 50. It is said that object B has a momentum of 70, so if we can draw object B on this graph of A, it would be somewhere there with an initial momentum of 70. Before the collision, we have both the momentum of A as well as B. After the collision, we have the momentum of A from the graph, and we can then calculate the momentum of B by using the law of conservation of linear momentum, which gives you an answer of 100 kilogram meter per second west.